All right, today we're going to talk about, like I said, analyzing graphs. We're going to talk about average rate of change, odd, even, neither functions, finding zeros, just kind of a hodgepodge of stuff. The first few slides we've kind of already gone over, so I'm just going to kind of review it, talk a little more about it. You guys have a homework assignment that is due on Monday. So I'm not going to get through everything today. I'm going to get through most of it. Tomorrow I'll return your quizzes. We'll go over the quizzes. You guys will be able to work on your homework. I'll finish the lesson. And then we'll start 1.5 on Monday. So next week we're going to, Monday, Tuesday, go over section 1.5. We're going to review Wednesday and take our first test. Okay, next Thursday. So we'll just have this stuff and then what we're learning from 1.5. We're going to do 1.6 and just kind of attach it to chapter 2 for the first quiz. All right, so if I asked you guys to find the domain, what would the domain be of this function? Okay, why is -1 with a bracket? Because it's a closed circle. So we read from left to right. So -1 to what?
5.
To 5 with a parenthesis. Open circle, not included. Correct. What about range? It's the lowest point on the graph. -3, does it include or not? Okay, and then what? -3 to? +3. Good, included? All right, perfect. Now, when they ask a question to find f of -1 and f of 2, remember, this is in function notation. F of x is a fancy way of saying y. So when they say f of -1, they're saying, okay, I'm plugging in -1 for x in my mind. I'm looking on the x-axis where -1 is. What is the y value at that point? So at -1 on the x-axis, which is here, what is the y value? 1. So you would answer that question as f -1 equals 1. That's all that they're saying. If I say what is f of 2, that means look on the x-axis at 2, tell me what the y value is. And it's what? -3. So you would say f of 2 is -3. Does that make sense? Yeah. Thank you, dears. Thank you. Oh, look, we're talking about open and closed dots. We've already gone over this. Okay, we've already gone over that. If there is a closed dot, that point or that value is included. If it's an open dot, it is not included. Parenthesis versus brackets. All right, now we're going to talk about zeros. Have you guys heard the term a zero? Something is a zero of something else. All right, write this down. Zeros, roots, solutions, X-intercepts. All 4 of those terms mean the same thing. If they say to find the zeros of a function or to find the roots, tell me the solutions. What are the X-intercepts? All of those things mean the same thing. It says solve. You're plugging in 0 for y and solving for x. Right? If we were going to find x and y intercepts, if you want to plug in 0 for x, you find the y-intercept. Plug in 0 for y, you find the x-intercept. You guys learned that from probably middle school. 90% of the time in this class when you do this, you're going to factor. Factoring is not going anywhere. This first semester is really heavy on algebra, so if you really like algebra, you'll probably excel, probably do a little better. The second is based more so in trig and stuff like that. So it's just a different thought process a little bit. But zeros, roots, solutions, x-intercepts, they all mean the same thing. We're going to plug in 0 for y and solve for x. All right, you guys with me? All right, let's do a little review here. It says find the zeros of the function. Remember, f of x is a fancy way of saying y. So we're going to plug in 0 for y. You just set the equation equal to 0. I like 0 to be on the right, so I have 3x squared plus x minus 10 equals 0. We're going to factor. This is a quadratic. How do I know this is a quadratic? Because it's x squared. Good. How many answers am I going to have?
2.
Here's a little fact, little hint. The highest exponent is always going to tell you how many answers you have. Some may be real, some may be imaginary. But like when we get into some bigger equations, or maybe x to the 5th, x to the 6th. When you start off, you go, okay, it's x to the 6th, the biggest exponent. I know I'm going to have 6 answers. So I know I'm going to have 2 answers here. I could use the quadratic formula. That would take us a lot longer than needed. So let's see if this factors. How would I factor this? This is a this is a trinomial where a is not 1, meaning the first term, a, is not just plain old x squared, it's 3x squared. So what do I do? Okay, how do we factor? You guys, there's a bunch of different ways that you were taught, but I'm going to say, okay, a times c. 3 times negative 10 gives me what? Negative 30. What are the factors of negative 30 that multiply to give me negative 30, but add to give me a positive 1? Positive 6 and negative 5. Okay, now you guys probably factor differently than I do. I was taught this trick a very long time ago, and it just kind of stuck with me. A lot of you guys guess and check, something like that. This is how I do it. I take, since a is not 1, it's 3. I'm going to take that a term and divide both my factors by it. What is 6 divided by 3? 2, so this becomes x plus 2. Does 5 divide by 3 nice and pretty? So this becomes your coefficient. It's 3x minus 5. Again, if you factor that differently, feel free. Now I'm trying to find the solutions. I'm trying to find the answers. So now what do? I set each piece equal to 0. X plus 2 equals 0. 3x minus 5 equals 0. Subtract 2 from both sides, and x equals negative 2. Great. I'm going to add 5 and divide by 3, and I get x equals 5/3, 5 over 3. Good. So remember at the beginning, we said how many answers are we going to have? 2? Did I come out with 2 answers? Yes. Good. And we're going to do more. Our next chapter is quadratics, and it's going to be full of factoring. So get excited. I like to factor. All right, look at B. B's a little different. This isn't a factoring problem. But the first thing we're going to do is plug in 0 for y. So I have the square root of 10 minus x squared equals 0. How do I solve this? How to get a square root to go away? You square it. What you do to one side, you do to the other. When we square a square root, it cancels out. So I have 10 minus x squared equals 0. Keep going. What do?
X squared.
Move x squared to the other side. That's fine. I'm going to move 10 to the other side just because I'm a wacko and I have to have my variables on the left-hand side. It just makes me feel better in life. So negative x squared equals negative 10. Did I create one extra step for myself? Yes. But it just makes me feel better to have it on the left-hand side. What do I need to do now? I got to divide everything by negative 1, right? So I have positive x squared equals 10. And now I take the square root. When I put the square root on top of a number, what goes in front of my answer? Plus or minus. So x equals plus or minus the square root of 10. Somebody asked me, first period, do we break this down? You guys, don't ask yourself that question anymore. Just do it. We always simplify. We always break down. Does the square root of 10 break down? No. But if that was 20, yes, it would break down to 2 root 5. So always, always, always simplify. Always break down that radical if you can. Questions? All right, next one. First thing I'm going to do, h of t. Does it matter that it says h of t? No, just put in a 0. I'm going to change my variable to x's because after one step, my t becomes a plus sign and I get confused. So it's 2x minus 3 over x plus 5. At any time, if there's variables and you guys don't like the letter for whatever reason, you can always change it. You don't have to ask. All right, let's test our algebra skills here. How in the world do I solve this? Perfect. Multiply both sides by x plus 5. What happens on the right-hand side? What's x plus 5 times 0? 0. What happens on the left-hand side? This cancels, so I have 2x minus 3 equals 0. Now what? We're going to add 3 to both sides. Okay, so 2x equals 3. And divide by 2. So x equals 3 over 2. So if you were to graph this, x equals 3 over 2, what does that tell you? It's a what? No, not necessarily, because look at your function's not a straight up and down line. But what is the graph gonna do? Oh, sorry, over here. What is the graph gonna do at 3 over 2? It's gonna what? It's the intercept. It's where it's gonna cross the x-axis. Your solutions, your roots, your zeros, your x-intercepts are all interchangeable. It's where, if graphed, or when you graph it, it's where the graph will cross or touch the x-axis. Questions? Little mini finding the zeros lesson, okay? Scooting along. We already know this. We're just talking about vocabulary and stuff. It says use the graphs to describe the function behavior. We just took a quiz on this. How do you read a graph? From left to right. So if I were to put my pencil on the left-hand side of this graph, this function, what would you guys explain? How would you describe this graph? It does what? It's increasing. Perfect. This graph is increasing. Going up. What about this graph? It's what? Increasing, then there you go. So increase, decrease, increase. Good. Just getting terminology. We'll talk about end behaviors of a graph, what the ends of the graph are doing later on. But right now we're just talking about the behavior of the graph itself. So this one is perfect. Increase, decrease, constant. Good. All right. Relative minimum and maximum. We've already discussed that. We're good to go. Now we're going to talk about something called average rate of change. You guys already know how to do this. You already know what it is. You just don't know it yet. If I wrote this, and I said to you guys, what's the slope? 2 over 3, right? That's average rate of change. This is a slope is a specific average rate of change because it only applies to what kind of lines? Straight ones, right? It only applies to straight lines because in a straight line, your slope is constant. From one point to the next, it's the same. When you have a function that has a higher degree than 1, x squared, x cubed, x to the fourth, you have what's called an average rate of change. It's the rate that the function changes over an interval. So, how do you find the average rate of change? Anybody have any idea? They gave us all of the information that we need. Bye, sweetheart. Have a great day. They gave us a function, yes? And then they gave me 2 x values. I know you guys can look at the graph, but I want to do this algebraically because you're going to do it algebraically in your test. If they give me the function x cubed minus 3x, and they give me 2 x values, they tell me, well, one of the x's is negative 2, and one of the x's is negative 1. Plug it in. When I plug it in, what letter am I finding? Yes, because f of x is a fancy way of saying y. Okay, so watch. When we plug this in, we have negative 2 cubed minus 3 times negative 2. What's negative 2 cubed? Negative 8. And then negative 3 and negative 2 is? So plus 6. So y equals what? Negative 2. Okay, all right, over here, same thing. Negative 1 cubed minus 3 times negative 1. What's negative 1 cubed? Negative 1 plus 3 equals what? What is it? No, you're fine. I got you. All right, well, how did that help us? Did that tell me the average rate of change?
Gave you the point.
It gave me 2 points, didn't it? It gave me the points, negative 2, and it gave me the point -1, +2. Average rate of change, guys, is just it's a broader concept, broader term, because we can use it for any function, but you just find the slope. Use the slope formula. So y2 minus y1. I'm going to say -2 minus 2 over -2 minus a -1. You guys agree? Lots of -2's in there. Did I write them correctly? What's a -2 minus 2? -4. -2 plus 1 is -1. So my average rate of change over the interval of x is -2 and x is -1 is +4. Now, if you have a positive rate of change, that means your function is doing what? Increasing. Let's check our graph. If I go from here to here, follow the function, what's it doing? It's increasing, it's going up. So if you have a negative rate of change, what's your function doing? Decreasing. Very good. So if they ask us, and they did, for the average rate of change over the interval of x is 0 and x is 1. Okay, we're going to do the same thing, guys. Plug in 0, so 0 cubed minus 3 times 0 gives me what? What is it? 0. Okay, thank you. That was scary for a second. So 0, 0. Now I'm going to plug in 1. 1 cubed minus 3 times 1. What's 1 cubed? Minus 3 is -2. So I have the point 1 comma -2. How do I find the rate of change over this interval? The slope formula, y2 minus y1. So -2 minus 0 and 1 minus 0. -2 over 1. Yes? Okay, so from this point to this point, follow your function. What's it doing? Decreasing. So it should make sense that our average rate of change is negative. So on a test or a quiz, I'll just give you a function and 2 x values. You have to plug the x values in to find the y, then use y2 minus y1 over x2 minus x1 to find the average rate of change over that given interval. Absolutely nothing mathematically new in that. You guys have done slope a gajillion times. It's just understanding that average rate of change is not consistent. It's not constant in any function other than a straight line. It'll change. You can have the same algebraic function, whether you look at a graph or written like x cubed minus 3x. And every every x value I give you, it'll be different because it's not constant. Okay, here we go. Even odd functions. I like these. So just read the slide and then you guys will get it, okay? I'm just kidding. We're going to test. We're going to figure out if functions are even or odd. 2 different ways we're going to do it. Graphically and algebraically. So a function is even when its graph is symmetric with respect to the y-axis. What does that mean? If something is symmetric to the y-axis, that means the y-axis does what? Cuts it in half. If something is symmetric, it's the same on one side or the other. A function is said to be odd if its graph is symmetric with respect to the origin. That means it goes through the origin. So graphically, this is graphically, write this down. This is Mrs. Meadows' definition. You have 2 kinds of functions, either even or odd. If it doesn't fall into one of these categories, then it's neither. So an odd function, there's 2 things that has to happen graphically in order for a function to be odd. First of all, the arrows, the ends of the graph, arrows in opposite directions. That means 1 up and 1 down. And has to be both things. It has to pass through the origin. What do you guys notice about the word odd, opposite, and origin? All begins with an O, right? Should be pretty easy to remember. So a function is odd. Graphically looking at a function, it's odd if the direction of the arrows are opposite, one up, one down, and it passes through the origin. If it does not do both things, then it's neither. A function is even if the arrows go in what direction? The same direction. Good. Arrows in same direction. And symmetric to y. Meaning the y-axis cuts it in half. Right? If those things both don't occur, then your function is neither. You probably won't have any questions, maybe one, that asks you if the function is odd, even, or neither by a graph, because it's very simple. Opposite directions and through the origin, odd. Same direction, either both up, both down, and the y-axis cuts it in half, then it's even. Now, algebraically, does anybody remember doing this algebraically? I know Algebra 2 honors definitely did. Yeah. First period, they were like, I said, how about any of you remember it, but have absolutely no idea how to do it? They're like, oh, that's me. That's fine. It's totally fine. You were probably taught to plug in negative x into a function.
Yeah.
Okay. I find that to be confusing. I'll show you guys what I mean by that in a second. I find that to be confusing, so I have a little shortcut that I do. So, algebraically, okay? If I give you a function, I say, is this odd, even, or neither? You can't just look at it and tell. Some of them you can, but we're not going to because you guys are going to algebraically means show me the work, prove it. So the way that you would algebraically, you guys don't have to write this down if you don't want to. The way that you would algebraically do this is here's my original function, yes? I'm going to plug in negative x. So if I plug in a negative x here, I have negative x cubed minus a negative x. So negative x cubed, what's minus a negative? Plus x. What do you notice about these two? They're exact opposites, right? Sometimes it's not too hard to plug in a negative x. Sometimes there's a lot of variables and your negatives can get lost, and then it's hard to compare from the beginning to the end if they're exact opposites or not. So this is what I do. Feel free, if you're comfortable with plugging in negative x, that's totally fine. But this is what I do, and this will work every time. All right, we're going to pick a number, any number in the world, bigger than 1, so 2 or higher. And you're going to use that number and its exact opposite. We're going to show if something's even, odd, or neither. So the first thing I'm going to do is I identify what kind of a function this possibly could be. We look at the highest exponent. The highest exponent is a 3. What kind of a number is 3? Odd or even? Odd. So this function can either be odd or neither. If the highest exponent is an odd number, it can never be an even function. We just don't know if, now we know, since it's an odd exponent, you know the direction of the arrows is opposite, but you don't know if it goes through the origin because we don't have a graph. You're not using graphing calculators. This is why we algebraically figure this out. All right, I want these first 2 rows, you guys use 2 and negative 2. These middle 2 rows, you guys use 3 and negative 3, and everybody else use 4 and negative 4 when we do this example, okay? I'm in the middle, so I'm going to do 3. This is how we're going to set it up. I'm going to say negative 3 and positive 3. And then you're going to have 2 answers here. Now, what was one word that was really important about the direction of the arrows in an odd function? Opposite. So I'm going to put that right here. If this is an odd function, the direction of the arrows is opposite. Okay, so now, guys, use the number that I assigned you, but plug in your number, negative 3 and positive 3. Plug in negative 2, positive 2, negative 4, positive 4. Go ahead, evaluate. Use your function that they gave you. So I'm going to use negative 3 cubed minus a negative 3. And then I'm going to say positive 3 cubed minus 3. So on my side, negative 3 cubed is negative 27. minus a negative would be plus 3, so I get negative 24. If you use negative 2, what did you guys get? Negative 6. Okay, if you use 4, or negative 4, what did you guys get? What is it? Now I'm going to go over here and use positive. So 3 cubed is 27, minus 3 is 24. When you use 2, what'd you get? 6. When you use 4, what'd you get?
12.
We use negative 4 and 4. So negative 4 cubed minus 4. Minus the negative to be plus, right? What's negative 4 cubed?
16.
Negative 64, right? Yes? Plus 4 gives me negative 60. And if I use positive, so 4 cubed minus 4, 64 minus 4 is 60. Yes? What do you guys notice about 60 and negative 60? Or negative 24 and positive 24? Are they opposites of each other? Then that means this function is odd. The value that you get is not a big deal. That's why you can use any number in the world. It's the relationship between your two answers. If your function is odd, then when you evaluate using any number bigger than 1 and its exact opposite, your answer should be exact opposites. If they're not, then the function's neither. We're going to practice this more. Now, again, if you're more comfortable plugging in negative x and then comparing, you're more than welcome to. I just think this is easier for us to kind of wrap our head around. If we look at the next slide, we're going to look and see if this function is even. I'll use 5 and negative 5. So I'm going to use negative 5 and 5. If you want to use 2 and negative 2 every single time, it'll work. What do you think, what word I'm going to put in between my two answers if I think the function is even? Same, because the arrows would be going in the same direction. My highest exponent is 2. That's an even number, so this is either an even function or a neither. So when I plug in negative 5, what's negative 5 squared? It's negative 5 squared. 25 plus 1 is 26. Over here, I plug in positive 5. What's positive 5 squared? Plus 1 is, are those two numbers the same? So then your function is even. Now I started off here with an x squared, yes? So the only two options for x squared is even or neither. So say I worked this problem out and I came out with negative 26 and positive 26. Are those the same? No. Are they opposites of each other? Yes. Would you then say, oh wait, maybe it's an odd function? No. An even exponent can never ever be an odd function and vice versa. If the highest exponent is odd, it can never be an even function. So if it randomly works out that the number you choose gives you exact opposites, but you're looking for it to be the same, then it would be neither. It's never going to switch to the other. Does that make sense? Graphically, this is how you guys would look at this, and then I'll finish this video tomorrow. I'll do the examples and stuff tomorrow. If you're given a graph and it says, determine whether this is odd, even, or neither, the first thing you should do is look at the ends of the graph. Circle it so you can visually see it real easily. What's the direction of these arrows? They're going in the opposite direction. Good. Does the graph pass through the origin? Yes, it does. So that means this is what kind of a function? This is an odd function. It has to do both things. If it looks like this, would you guys agree with me that the arrows are in opposite directions? Yes, but does it pass through the origin? So it would be what? Purple would be the neither. Good. So same thing over here. Look at the ends. What direction? Both going the same. Doesn't matter that it's both up or both down. It's just same direction. Does the y-axis cut this in half? Yes. So this is even. If you had something like this. Pretend those are the straightest lines you've ever seen in your whole life. Direction of the arrows. Same, okay. Does the y-axis cut this in half? No. So this is neither. Graphically, that's all you have to do. Look at the arrows at the end and then determine, could it be odd, could it be even? And then the second characteristic, does it go through the origin or does the y-axis cut it in half? Does that make sense? Okay, so tomorrow, I'll finish the examples. If you guys want to work on them tonight, you can. I will give you guys back your quizzes tomorrow, and I will also let you work, maybe even together, but on your homework that's due Monday, so you don't have to do anything over the weekend. So algebraically and graphically, we're going to talk about odd, even, neither. All right? If I look at this first question, what are the possibilities that this function could be? Odd or neither. Cannot be even. Why can it not be even? Because of the highest exponent. Perfect. The highest exponent is 3. That is an odd number. So your two possibilities could either be odd or neither. This is what I expect to see on your homework, as far as work is concerned. And this is also what I expect to see on your test when you guys have your test next week. You're showing me, you're proving to me algebraically whether this function is odd, even, or neither. Again, if you want to use -2 and +2 for every single one of these problems, feel free. It will work every time. What would the answers that I get from this problem be in comparison to each other if this was an odd function? They would be opposites. So I'm going to put that right here just to remind myself, okay? So now we just do some basic math. You need to be careful with your parentheses and your negative signs. We always make little silly mistakes here, and then it could definitely change the problem. So -2 cubed is -8, right? -6 times -2 is +12. -8 plus 12 is what? 4? Okay, great. So same thing over here. I'm going to say 2 cubed minus 6 times 2. Well, 2 cubed is 8. Minus 12 gives me -4. Are those two numbers exact opposites of each other? Yes, so your answer to this problem is odd. So on your test, if you show me all this work but don't say odd, even, or neither, you're not answering the question. If you show me no work and tell me odd, even, or neither, you're not answering the question. So I need to see everything. If you guys are comfortable with plugging in -x, you are more than welcome to do that. I just think this is a little easier for us to see. But again, do what you want. All right, let's look at number 2. What are the possibilities for 2? Even or neither, okay? Cannot be odd. Yes, I understand there's an odd exponent in there, but we go based upon the highest exponent that you see. So this could either be an even or a neither function. So again, if you want to use 2 and -2, feel free. You guys want to use something else, go ahead and then look at your answers compared to mine at the end, that's fine. But if this were an even function, the two answers that I arrive at the end of this will be what? The same. Very good. So let's check. So I have -2 to the 4th power minus 2 times -2 cubed. What is -2 to the 4th power? 16. All right, and then -2 cubed is -8, right? So -2 and -8 is plus 16. 16 and 16 is 32. So scooting along over here, 2 to the 4th minus 2 times 2 cubed. 2 to the 4th is 16. 2 cubed is 8, so I have -2 times 8 is minus 16. 16 minus 16 is 0. Do you guys see how important signs are? Very easily, we could have made one teeny tiny error in signs and come out with, oh, they're the same, it's an even function. Just make sure you pay attention. Take your time. This is very basic computation, I know that, but just take your time so you don't make any silly mistakes. Is this function even or neither? This is a neither. If you wanted to just go like that, that's fine. You want to write neither, that's fine. All right, this one got chopped off, so we'll just make our own problem here. Let's make this cubed and this one squared. Is this written in standard form? No. Don't get fooled by that. You don't look at the first exponent, we look at the what? The highest. So my highest exponent here is a 3. So this function is either odd or neither, correct? So I'm just going to, again, use -2 and +2. If this function is odd, what are the answers going to be of each other? Opposites. Good. I'm setting it up the same way every time. So -2 squared plus 2 times -2 cubed plus 1. And now just simplify. -2 squared is 4. -2 cubed is -8. So 2 times -8 is -16, right? Plus 1. What's 4 minus 16? -12 plus 1 is -11. Good. So over here, same thing. 2 squared plus 2 times 2 cubed plus 1. Somebody last pair is like, oh, if I can already tell it's going to be, no. I want to see all of the work. Show me, prove it to me. 2 squared is 4. 2 cubed is 8. So 8 times 2 is 16, right? What's 16 and 4? 20 plus 1 is 21. Are those numbers exact opposites? No, they're opposite signs. Agreed, one's negative, one's positive, but it's not -11, +11. It's not -21, +21. They have to be exact opposites. So my answer here would be neither. Questions? Is this super hard? Okay, good. All right, let's look at number 4. Options. Even or neither. Why is it those two? Yep, your highest exponent is an even number. Good. So let's do, I'm going to do 8. -8 and +8, just because I feel like it. Okay, so if this is an even function, the answers are going to be the same. Good. So I have -8 squared plus 6. What's -8 squared? 64 plus 6 is 70. Okay, so now over here I'm going to say 8 squared plus 6. What's 8 squared? 64 plus 6 is, oh, what do we notice here? It's the same. So this is what kind of a function? This is an even function. Great. As long as you use something 2 or bigger, the number and its exact opposite, you guys will be good. Options. Odd or neither. Okay, this can be odd or neither. So let's do 3. -3, +3. If this is an odd function, my answers are going to be opposite. Good. So 2 times -3 cubed plus 7. What's -3 cubed? 3 times 3 is 9 times 3 is, okay, -27 times 2. -54 plus 7. -47, good. Now over here, same thing. I'm going to have 2 times 3 cubed plus 7. So 27 times 2 is 54. 54 plus 7 is 61. It's not -47, right? So what is this function? It's a neither. Great. Again, you guys are welcome. You're welcome to plug in -x if you want. I just find that can be a little confusing. Sometimes when you plug in a -x, part of your function is exactly the opposite of the original, and then the other part's not, so it's kind of hard to determine if it's odd or not. I think it's just easier to use numbers, but you guys are welcome to do what you want. Graphically, if you guys are given a graph, yes, sure. If you're given a graph and you have to determine if something is even or odd, so let's remind ourselves, an even function, arrows are in same direction. Up or down. And your function is symmetric to the y-axis, meaning the y-axis cuts it in half, evenly on one side or the other. It's odd if the arrows are in opposite directions, meaning up or down. I should have done this over here, like. And this has to pass through what? Has to go through the origin. Got to do both. So if I look at this first example, number 6, okay, obviously I drew this by myself, so pretend that it's perfect. The arrows are in same direction or opposite? Same. They're in the same direction, okay, so that's good. If I think they're in the same direction, then I look at the y-axis. Does the y-axis cut this thing perfectly in half? Yes. So then this would be an even function. I look at 7. Look at the arrows. Are they in the opposite directions? Yep, great. So this could be an odd function. Does it pass through the origin? No. So this is a what? Neither. Has to do both things, kind of like our perpendicular slope. Has to be negative, or opposite should say, and the reciprocal. Can't just be one. It's got to be both. So now I look here. Arrows are going in. Opposite directions, yes. Does it go through the origin? Yes. So this is odd. Does that simplify things a little bit? Okay, awesome. Good job. Very good job, ladies and gents. Okay, so now I will upload this in a minute, but let's look at our homework, okay?